everyone. Today I'm going to be looking at using the new feature of Flowcode 11, which is serial debugging using In Circuit Debug through a USB to serial adapter. To show you this, I'm going to create a quick project. So I'm going to choose an embedded target, I'm going to choose an Arduino, and from the list I'm going to choose an R3 surface mount. I'm going to select my programming port. On some devices this may be auto-detected for you. And I'm going to go into my project. Once the environment is loaded, I'm going to add a couple of component libraries into my program. So I have, let's show you my setup. So I have a Arduino Uno R3 surface mount, and I've got connected a DHT22 temperature humidity sensor, and I've got an LED connected. Okay, so let's add some component libraries to talk to those two devices. So I've got my LED, so under outputs LED, let's add an LED, and let's connect it to pin D7. And then under sensors, temperature, humidity, DHT22. And this is connected to pin D10. So my program is going to be very simple. I'm going to create a loop. I'm going to sample the sensor. So 0 for success, 2 for a checksum error, and any other non-zero for a comms error. So let's have sensor sample status, and then we want to get the temperature as a floating point. Let's create a floating point variable called temperature. And I want to do something simple like if the temperature is above a certain threshold, then I'm going to turn on my LED, otherwise I'll turn it off. And let's add a little delay so we're not rattling around the loop super fast. So let's add 100 milliseconds. So first things first, I can simulate this program. So if I vary the temperature here, and we should see the LED come on once the temperature goes above 25. Okay, so the simulation works great. So we can program this to the hardware. So it's asking me to save it, so let's have DHT22 temperature. I have unplugged my Arduino. It's never going to work. So let's go in and select the right serial port. There we go. Let's program the Arduino again. So that's programmed now. Let's bring back up the camera, and you can see there we have the Arduino working away. If we add a bit of temperature, then there the light comes on. Excellent, so it works. But really, what's going on? It's a black box. We have no indication. Now we could start sending values back across the serial COM port. But really, what we want is a full access to the program as it's running. Let's turn off my camera again. So if I go back to the debug menu and I enable ICD, you see the icons turn green. Now, once I've enabled this, I also have to reprogram the device, because this has basically added a load more code into the background C code to allow us to do things like the ICD step through. So I've programmed that again, and now if I go back to debug, well, I can run the program, and there it is running. I can pause the program, and here's where we are. So let's say I want to set a breakpoint after the temperature's been sampled. So if I right click here and toggle breakpoint, if I run again now, you see the program ran until we hit the breakpoint, and up here I can start to do things like look at the values of the variables. So temperature is currently 22.6. As well as being able to look at the variables, I can also directly write to them. So if I bring back my webcam, if I change, if I select the right thing, it's interesting, doesn't want to move. If I move this so we can see it, if I update the value of temperature here, so if I set this to 28, and then step through my program, so if I step into, and you see the LED has come on. So we've overwritten the variable value in the program. Now this works for global variables, but I don't think it works for local. So if you want to have control over variables and see what they're doing, you just make it global, and then you have full access to it. Okay, so let's hide my web camera again. So you can see we've got really nice control over it. So we can step into, we can step over, so we can step over this decision. I believe you can also step into certain macros. Let's see if we can do that. No, I think there's a setting somewhere to allow you to do that. But anyway, we have a lovely debugging access here. So any device with a USB to serial type connection will work out of the box. So Arduino's ESP32 devices, all of the new eBlocks 3 hardware has this feature. There's many devices with USB to serial features. If anybody has their own device that they want to use with this type of feature, then all they need to do is have a UART connected to a USB to serial, and then they just need to come onto the Flowcode forums and tell us what device they're using, what pins their UART is on, and we can create them a custom target definition file for their device that has this ICD feature preset up for their UART. So I hope this is useful. Thank you very much. I've been Ben Rowland, and I'll see you next time.